Hello, everyone. I'd like to invite you to our next conversation about a very important topic these days, which is how software solutions are transforming the approach to manufacturing. Today, we are going to focus on robotics and how certain software solutions can augment what the robotic application does. That's why I invited Simone from our Italian team to give us insights on how this is done on the electronic market. So Simone, welcome.
Thank you, Piotr. I'm Simone Farruggio and I'm in charge of robotics for Mitsubishi Electric Italy. And I'm pleased to share today some insight about electronic market and how we address the challenge of the market thanks to robotic solution.
Very good. And I think this topic is quite interesting when it comes to the electronics market because it faces its own challenges, and we can then see how this can be faced with robots combined with proper solutions based on software packages. So I think it's going to be a conversation with many themes. Therefore, I'd like to start maybe outlining the big picture first. So could you give us a snapshot of how the electronic market looks like now these days?
Yes, with pleasure, even because this market is a fascinating crossroad. Let's say that traditionally, Europe was overshadowed by Asian production. In fact, actually, we can observe mass production in Asia due to the cost of the labor, the availability of raw material, the government support, and of course, a high level of automation in their production. Instead, in Europe, we have a very strong know-how, and often the production is related to custom electronic board or some special components. Let's say that for robotic is a very important market because according with our studies and the International Federation of Robotics, electronic market is one of the top two sectors for robot deployment alongside automotive market.
This is very significant for Europe, as you said. So could you outline why these changes are happening right now?
Yes, we can consider different factors, different drivers why this is happening. For sure, a COVID pandemic accelerated this process because showed which are the vulnerability, the problems to have a distant supply chain because a lot of electronic suppliers were located in Asia. So the shortage of semiconductor impacted all the rest of the world. So bringing to a reevaluation of the strategy, of the supply chain strategy. But it's not the only one driver, even because before we spoke about automotive market, and automotive is changing, is shifting to electric vehicles. So this will increase the demand for electronic board and other circuits in general, semiconductor components for electronic market, for automotive market, sorry. Sure. And another driver we can rank between these is the government fund. There were huge investment at European level, and the European Chips Act is a clear example. But also at the national level, we have a different investment that can support companies to automatize their production and be more competitive worldwide.
So it sounds like this will translate into significant growth of this market in Europe. How do you see this? How do you expect the market to grow in the coming years?
the coming years, let's say that I see a different changes. Until now, the automation was related mainly to big company. Now we are observing that also small and medium enterprises are approaching robotics and automation. So I think that this change of paradigm will be very soon reality.
So I think that what you are outlining is very positive for Europe, and I think that we need some positive information for the European manufacturing, and I'm glad that that means electronics will be a very important market that will be developing in Europe. So I think we could discuss how these manufacturing facilities look like and what do they struggle with. So maybe let's start with the major challenges of those companies. So could you outline what kind of challenges the electronic market is facing these days?
We can say that the biggest challenge is for sure the shortage of skilled workers. Even because in this period a lot of experienced workers are retiring and not enough young workers are entering in the market. So, for example, soldering is a very critical application in the electronic because this process needs a lot of experience and an extensive training. So, companies in electronic market right now are struggling for this. And second, another challenge they are facing is the volume, because as we said before, the mass production is mainly related to Asia. So in Europe we have a production that is characterized by low volume and high product mix. So this means that this company needs to have a flexible solution, flexible equipment that can be adaptable to different format, different changes. And for sure, when we speak about small and medium-sized enterprises, they face the problem of the budget because they do not have a huge budget behind to automatize their production, and this is for sure to take into consideration. Last but not least, we have also a lack of knowledge because over the years all the knowledge was developed in Asia, and here our know-how is limited to some specific component. So for this reason, we try also with the small and medium enterprise to share the knowledge that we develop in Japan and all Asia.
Clearly, the electronic market faces those challenges, and like many other industries, but I think electronic market shows how important those problems are, right? You can't really manufacture without skilled workers, right? And of course, this is one of the reasons why there is more and more investments in robots and in making production more automated and robotized. So how do robotic solutions fit specifically into those electronic market needs?
In general, robotics brings speed, so faster cycle, bring also precision, so repeatable activity, and last flexibility. They bring flexibility to your equipment. Specifically from electronic market, we need to start from the requirements, from the risk. And one of the biggest risks in the electronic activities are the electronic discharge. So this is the reason why we do perform some modification of our standard robot to develop a tailored solution for electronic market that there is a certification that is called ESD, And our robots are ESD compliant, certified by an international body, certificator, that is called ESD Academy. And in comparison with our standard model, the ESD model, for example, have a special paints to avoid any discharge or rubber cap that eliminate completely the risk of electronic discharge, so eliminating the risk to damage the electronic board or the semiconductor component. In addition, we can say that a lot of activities in electronic market are performed in controlled area. So, because the contamination of dust or other particles can damage the electronic board. So, for this reason, we certified as a standard our robot with the ISO class certification. So this certification is given certified by Fraunhofer, and of course is another international certified body. And this allows our robot to work in a controlled area as a lot of activities occur for the electronic market.
Right, so this what equips robots with the ability to actually solve manufacturing challenges in the electronic production. But I mentioned earlier the point about the precision, and clearly these days everything is getting smaller, and of course it is very important that the electronic components are small. So how does a robot solve this challenge where you have to be extremely precise in assembly?
Yes, you clearly mention a key point for electronic activities, because precision is required for many processes in the electronic, and from our factory they spend a lot of time studying this problem, and at the end they develop a dedicated function that increase the repeatability of our robots. You can easily enable this function adding an external hardware directly to the controller, and the robot will be more precise independently from temperature changes. In addition, we can say also that all these, let's say, data from production, precision data, test, because the precision is always, it's often used not in assembly but also in quality check to see the exactly position. So all these data are saved into our IQ platform, in our automation platform, because we have a model that is fully integrated with our PLC, and thanks to it we can collect all the data and share with a dedicated protocol in the semiconductor market. This protocol name is SexGem, and thanks to this complete ecosystem we can collect all the data of the process and sharing with all the other system.
It's important to note one point about how do you actually assemble the product, but also how do you report that precision further, right? So I think that's a good point. So we have this picture now where the challenges in the manufacturing of or electronics assembly are met with advanced robotic solutions. And I think it's worthwhile to also mention that the one thing is the precision of the robot arm, but the second one, this kind of a little bit intelligence-enabled precision given by these special features that you mentioned. So all of that, I think from the, let's say, pure production perspective, sounds great. However, what about the effort of implementation of robotics solutions? And I think this is when the software value comes to mind, right? So the problem that we still have in front of us is the implementation of the robotic solutions. So there is a lot of discussion how, for example, digital twins are simplifying the approach to design and deployment of various applications. And I assume that also fits robotics. So how do you see digital twins helping manufacturing companies to use the robotic applications?
Digital twin is strongly impacting also robotics, is a game changer because digital twin allow us to design the machine, validate, program the machine before a single piece of hardware is mounted, is constructed. So for all the companies that struggle with budget problems, with that they see very difficult to integrate robotics in their manufacturing dimension, let's say that we support them thanks to digital twin, and this means this create a real bridge between the virtual dimension and the physical dimension. And this represents a booster for the automation for all the company that before were, let's say, were not so prone to approach automation.
Yes, because you can understand a lot about specific application just by looking at digital representation. I think that's definitely changes the approach to planning and decision making for automation investments. Yeah,
and for that company who wants to approach to automation and robotics, let's say that allow this company to see their idea, to see that their idea works in their production environment. So this makes the difference when someone look virtually exactly their production environment and their concept working on it. So this for sure, let's say, something that brings value.
Right. When we are talking about how this digital twin approach helps in creating those kind of applications, maybe we should focus on specific types of applications. So I assume there are very certain types of robotic applications that can be deployed in the electronic manufacturing. So maybe you could outline what are these typical types of applications and how digital twin is supporting creation of those.
Yes, of course. Let's say that 3 typical applications we every day see on with our customer are for sure loading and unloading of the electronic board, so machine tending for electronic board. And this typically happen with the test machine. So typically the robot load the electronic board into the probes on the fixture machine and then unload the electronic board when the test is completed. Let's say that in this case Gemini was fundamental because we can calculate, because one single robot in the last project we made, one single robot was loading and unloading with 2 different test machines. So the calculate of the cycle time was very important to understand how the robot cycle can be developed, let's say. So in this case, the impact of the digital twin was fundamental. Another application we already mentioned is soldering. In soldering, let's say that the difficulties can be related also to the path of the robot. In this case, the integration between our software for programming robot and the virtual commissioning software, so Gemini, was very important because thanks to functionalities of our programming robot software, we easily make a complex path and then replicate just because they are integrated. So what I program in RT Toolbox, we can visualize on Gemini. Okay. So the program was very easy from a robotic point of view because we had a dedicated function, and then you can visualize soldering activity on Gemini. Mm-hmm. So, and last application that is very important is quality inspection. And in this, typically the robot integrates on the wrist a camera. On the camera is positioned in a fixed position. So we can say that to define the best layout of the application, the key was Gemini, because we try the two scenario with a fixed camera and with the camera integrated on the wrist of the robot, and we saw which was the more flexible solution to satisfy the need of the customer.
Right. And I think it's a very interesting summary of those benefits based on specific examples, because there is a variety of problems to be solved with the robotic applications, and I think that the key is to be able to do that by trial, but the trial that is cheap and it doesn't cost mistakes and hardware investments and so on. So I think that for those processes in manufacturing, digital twin is crucial. I think we can also say that the benefits of digital twin don't end with the, let's say, application development, right? So you mentioned how the program written for the robot can be then visualized in digital twin in Gemini. But the same is true when you actually have the application already running, right? So with digital twin, you can monitor the actual production and also start thinking about the improvements, right? So the digital twin probably gives you benefits through the whole life cycle of application. Would you agree?
Yes, totally. I totally agree, because when you have a machine already running, you can import the CAD of the machine, all the parameters in the digital twin software, and then simulate all the different scenarios. So I, for example, change a parameter or add a robot or change the layout of the machine. Is everything that you can do. Let's say, evaluate this scenario and then see the impact in terms of takt time, in terms of productivity, in general of OEE. So let's say that it allows you to determine which is the best scenario to improve the productivity of your machine. So exactly.
Right. Yes, because I think once you make the investment in the software package, like we mentioned, then of course the value of that tool will be provided through the time and through the actual process of manufacturing. And I think, with high mix, low volume production, those changes in the layout, some tweaks, how the robot works might be quite common. Yeah?
Yes, it happens very often, even because a custom board, for example, are very common in Europe. So you need to the changeover are very frequent, and different scenarios are always, let's say, present.
Yes, right. Great. I think that this gives us a very good understanding on not only how to create this type of applications in electronics market, but this exactly presents the value of software solution that I mentioned in the beginning. So robots themselves, they are very important due to to address the labor shortage, right? Due to their precision, all the certifications you mentioned, they are important for the electronics process assembly and other types of processes in the factory. But what they can do is definitely augmented by the digital twin that you mentioned, because the digital twin reduces the costs of implementation, kind of secures the application from mistakes and so on. It allows for a better monitoring, it allows for continuous improvement of the production line. So it shows that the robots and the software come together. And I think that could be a nice summary of our conversation. Simone, any final comments you would like to make today?
Let's say that during your speech, let's say, came into my mind just the final consideration, because now we were speaking about robots and software and digital twin. But in general, we see not just a single product integrated with the software, but we see an ecosystem, ecosystem composed by hardware and software. So a unique solution integrated that allow you, as you already mentioned, to monitor, to do maintenance, to define the best scenario. So I would speak about an ecosystem, hardware, software ecosystem, and a unique integrated solution.
I think that's a very good point. And I think that's so important that we will keep discussing this on our future webinars. So Simone, thank you for being here. It was a pleasure.